Today we will be graphing linear equations. And the method we're going to do today is called using a t-table. We can use something called a t-table to graph an algebra. We plug in values for x into the given equation and solve for the y value. Then plot the points on the graph and draw a straight line through them with arrows at both ends. So for this first example, our equation is y equals 3x. This is a t-table because you make a t. Okay, and this is a great way to start graphing any new concept. And I just choose some x's and I choose some easy ones. Low numbers, a couple negatives, a couple positives, and include 0. And then I simply plug each of these points into the equation for x. So for the first one, I'm going to plug in -2 for x. So it'll be 3 times -2, which is of course -6. And then I plug in -1. 3 times -1 is -3. I plug in a 0. 3 times 0 is simply 0. I plug in a 1. 3 times 1 is 3. I plug in a 2. 3 times 2 is 6. And now I have 5 points that I can graph on my coordinate plane. So I'll start graphing the first point, -2, -6. Then -1, -3. 0, 0, which is the origin. 1, 3, so 1, 3. And 2, 6, so 2, 6. If I do it correctly, all of my points should form a straight line. And now I just connect them as well as I can with a free hand and put an arrow on both ends. And I have just graphed the line y equals 3x. Something to notice about the table, if you notice the y's are always increasing by 3. So I'm going -6 plus 3 is -3, plus 3 is 0, plus 3 is 3, plus 3 is 6. So it's going up by that constant value of 3. And if you look in the equation, that is the number that is next to x. You probably remember that's called the slope. So that just tells us how much our points are changing in between each point. Second example is y equals x plus 3. Again, I'm going to use a t-table. I'm going to plug these points in. So first a -2. This time it's x plus 3. So when I plug in -2, it'd be -2 plus 3. If you want, you can write these down. That equals 1. Then I have -1 plugged in. So -1 plus 3 is 2. So this is a 2. Plug in a 0. 0 plus 3 is just 3. You'll probably notice already the table is going up by 1, which makes sense if you think about it, because the number next to x right here is a 1, right? It's a 1. We don't write it usually, but any variable has a 1 in front of it. So that means the y's are increasing by 1. So you can probably just follow the pattern here. The next number would be a 4. The next number would be a 5. So when I graph these points, first I go to -2, 1. Then -1, 2. 0, 3. I did not graph that correctly. My mistake. It should be -2, 1. This point is incorrect. -1, 2, 0, 3, 1, 4, 2, 5. Now, I don't know if you noticed, but after I graphed this point incorrectly, and then I graphed this one, and then this one, I knew this one was wrong because they weren't straight. So I went back and checked and realized this should have been up 1. So if your points aren't lining up straight, something's wrong. Then you connect them with a straight line with arrows on both ends. Here's a little more complicated example. I have y equals -2 plus x is my equation. I have my same t-table, so I'm going to plug numbers in. This time I plug -2 in for x, so it'd be -2 times negative 2 plus 1. Putting this negative 2 in for x. Negative 2 times negative 2 is positive 4. 4 plus 1 is 5. Then I'm going to plug in negative 1. So it'll be negative 2 times negative 1, which is 2. And then plus 1 is 3. Plugging in 0 is always very easy because it's going to make that term cancel out and become 0. So that would just be 1. And now if you look at the pattern, my table is going 5, 3, 1. We're subtracting 2 every time. And that makes sense because there's a negative 2 next to the x. Okay, and that negative 2 determines the change, how much y is going to change every time. So it's changing by minus 2. So 1 minus 2 would be negative 1, negative 3 if I want to continue the pattern. So now I'll graph these. First, negative 2, 5, negative 2, 5, negative 1, 3, 0, 1. Now my points are lining up, so I must have done it right. 1, negative 1, and 2, negative 3. Connect them together. Do the best you can on this. If you want, you can take a ruler. I have some rulers, and you could connect them with a perfectly straight line. But if you can do it pretty good with freehand, that's fine. One thing to notice, that the number next to x was negative this time, so the graph was going down from left to right. On our previous two examples, the number next to x was a positive number, so they were going up from left to right. Again here, the number next to x was positive, it was a 1, so the line's going up from left to right. That will always be the case. If the number next to x is positive, the graph goes up from left to right. If the number next to x is negative, the graph will go down from left to right. One more example. I have y equals 3. Here's my table. Now you'll notice there isn't even an x in this equation. Okay? So I have no place to plug these numbers in. Okay? So when x is negative 2, y is just 3. When x is negative 1, y is still 3. In fact, because it says y equals 3, y is always 3. So to graph this, I'd go negative 2, 3, negative 1, 3, 0, 3, 1, 3, 2, 3. You'll notice these make a perfectly horizontal line. The other equation you might see is simply like x equals 2. When that's the case, that means that the whole table, my xy table, that the x is always 2, no matter what the y is. So I can put any y in I want. And then when I graph these, I get 2, 1, 2, 2, 2, 3. Those are vertical lines. So y equals 3, that's a horizontal line. X equals 2, that's called a vertical line. Okay, and that'll always be the case. Now you'll try to do some t-table graphing on your own.